if a pilot is flying around the curve of the Earth, then he should be dipping the nose down every 5 minutes. He should be dipping the nose down to stay around the curve. But the thing that really got me interested was, as you say, the gyroscope. In a plane there is an artificial horizon, okay, and it's based on a gyroscope. And if you spin a gyroscope on a surface, it will want to stay upright. You can twist and tilt the surface as much as you like, the gyroscope will stay upright. So if a plane has a gyroscope and it starts following the curve of the Earth, the gyroscope would stay upright, which means the artificial horizon will start to roll backwards. But it doesn't. That's absolute proof that a plane flies over a flat surface rather than a curved one. Because I asked the pilot on my last flight, you know, do you ever notice the artificial horizon rolling backwards? He said, no, but the artificial horizon has complex electronics in it to make sure it knows where it is on the Earth and it compensates. But I went to the manufacturer of the artificial horizon, and they confirmed to me that it's completely mechanical, nothing electronic in it whatsoever. So it's literally just a gyroscope that can freely move. So that right there is proof to me that you know, planes fly over a plane.
Parallax conducted many experiments, all towards one conclusion: to prove that the surface of the water in the canal was indeed perfectly flat. In one experiment, a boat carrying a flag rowed from one bridge to another 6 miles away. An observer with a telescope placed 8 inches above the surface of the water found that the flag and the boat were distinctly visible throughout the entire distance. If the Earth is a sphere with a circumference of 25,000 miles, then over a distance of 6 miles, the second bridge should mathematically be 16 feet below the observer's eye line.
So when I heard about that experiment by Parallax in England, who used a flat 6-mile surface, floated a boat down there 6 miles, put a telescope 8 inches out of the water, 8 inches, and saw the entire boat 6 miles down when it should have been over the horizon, then you got to think, what's up? All right? The water wasn't dipped in the middle and came up like this. Water doesn't do that. Water's flat, people. Whatever container you put it in, water's going to become flat unless you keep shaking it.
If the Earth bends the water into a sphere around it, then if it was to freeze suddenly, we should detect a hump in the water, shouldn't we? So why is it that when Lake Baikal in Siberia freezes over, it is one of the flattest places on Earth, despite being 395 miles long and 49 miles wide? There should be a hump in the middle of it, nearly 20 miles high. So why haven't we ever seen curved water? Apparently we see a horizon about 5 miles away. So in 5 miles there's enough curvature to see a ship disappear, yet I cannot detect that curve over 10 miles, because I can see 5 miles to my left and 5 miles to my right, so I've got an uninterrupted 10-mile span in which I should see enough curve to hide 2 ships, but I don't. So if I see enough curve over 5 miles, why don't I see it over 10 miles?
The Earth isn't flat.
The resurgence of the flat Earth is not merely a handful of tinfoil hat-wearing crazies who lack intelligence and teeth. This is a shift in consciousness by ordinary people who have started to re-examine the lies they were told as a child.
Rivers run down to sea level, finding the easiest course, north, south, east, west, and all other intermediary directions over the Earth at the same time. If Earth were truly a spinning ball, then many of these rivers would be impossibly flowing uphill. For example, the Mississippi, in its 3,000 miles, would have to ascend 11 miles before reaching the Gulf of Mexico.
Some other examples include the base of the Isle of Wight, where water and land meet, forming a perfectly straight line 22 statute miles long. On the ball Earth, the Isle of Wight should decline 80 feet from the center on each side to conform to the curvature. However, the crosshairs of good theodolites have repeatedly shown the waterline to be perfectly level. And on a clear day from the highland near Douglas Harbour on the Isle of Man, the whole length of the coast of North Wales is often plainly visible to the naked eye. The 50-mile stretch has also repeatedly been found to be horizontal. On the ball Earth, however, the 50-mile Welsh coast would decline from the center a stark 416 feet on either side. The Dunkirk Light in southern France at 194 feet is visible from a boat, approximately 10 feet above sea level, from 28 miles away. At this distance on the ball Earth, the light should be hidden behind 190 feet of curvature. The light at Cape Bonavista, Newfoundland is 150 feet above sea level and visible from 35 miles, where it should be below 490 feet of curvature. The lighthouse steeple of St. Botolph's Parish Church in Boston is 290 feet tall and visible from over 40 miles, where it should be hidden below a full 800 feet of curvature. The Isle of Wight Lighthouse in England is 180 feet high and can be seen up to 42 miles away, where it should be below 996 feet of curvature. The Cape Lagulias Lighthouse in South Africa is 33 feet high, 238 feet above sea level, and can be seen for over 50 miles, where it should be below 1,400 feet of curvature. The lighthouse at Port Said in Egypt, at an elevation of only 60 feet, has been seen an astonishing 58 miles away, where it should be below 2,182 feet of curvature.
There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. Now, the Bedford Levels is a canal that is perfectly straight for 6 miles. Okay, so what a chap called Samuel Rowbottom did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend, in a rowboat with a flag on the back, row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance. Now, according to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 525 times 8, which is 200, works out, that's 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon. He shouldn't have been able to see the boat. Now, you know, the scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, you know, it's perfectly flat. And he in his book, he puts forward many arguments that show that, or many experiments that show the Earth is always perfectly flat. They say that you see the mast, you know, go down last. It's literally just the way your vision works. Yeah, it's perspective and atmospherics basically. The limit of your vision is supposedly 3 miles. And then after 3 miles, you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again says that, explains that you can't see the curvature of the Earth from a plane. He says this, you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature. Yet, you can apparently see a boat go over the curvature over the distance of 3 miles, which doesn't make sense. The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out of the sight of your binoculars, if you get a telescope, yeah, it comes back again. It doesn't go over any curve of the horizon. What we found, many people have done experiments with very high-powered zoom cameras, and they've watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears and starts, and the top of the boat inverts, so you see a sort of mirror image. And that, with your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometres away from the spire. So that should be over a mile below the horizon, and you can still see it. There's been a few famous examples just recently of a man who took a picture across the Great Lakes from Michigan and was able to see, I believe it's Chicago, which he shouldn't have been able to see. And the television station basically said it was a mirage.
This is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
But they always say it's a mirage, but for a mirage to happen, you have to have very specific atmospheric conditions. And there have been so many people who have seen exactly the same thing on different days, different seasons, always the same. It's not a mirage. It's simply that you're looking across a plane. You see in a kind of pyramid shape. Yeah, you have a horizon at your eye level, and everything above the horizon will go down into the horizon. Yeah, everything below the horizon will seem to go up. Just like if you're in a long hallway, you'll see that the walls will start to move in, and the roof and the floor will start to move into the centre. Yeah, so literally between you and the object you're looking at, there's all sorts of things, sort of like waves going up and down, and while you can't see them, if they're beyond the limit of your sight, sometimes they can still obscure what you're looking at. But it's just because they're between you and it, and it's just the way, it's literally perspective. It's better if I could draw a diagram, but it's a very difficult subject to get your head around if you're not used to it. But it is perspective. One sort of other proof is there's a place in Bolivia called Salar de Uyuni, which is a salt flat. It's literally 100 miles wide one way and 80 miles across, and it's perfectly flat. And when it rains, literally you get an inch of water, and it looks like a perfect mirror. Now, how does that happen on a sphere? Yeah, it shows you that, if you're one end of this salt flat, you can see perfectly clearly the other end 100 miles away. So it's just showing you that the Earth is flat, and without the effect of the waves in the sea, you'll be able to see a whole lot further.